Our next class of compounds are the ethers. This is a carbon with an oxygen in between and then another carbon. General formula is RO, R prime. Recall that R just means hydrocarbon chain, and that R prime also means hydrocarbon chain, but it indicates that it could be the same hydrocarbon chain or possibly a different hydrocarbon chain with a different number of carbons or a different way of being attached. I will not be talking about the physical properties of ethers at the moment. I will return to that later on. Now, let's work on the naming of ethers. When naming ethers, we follow the standard rules. We're going to look for the longest continuous carbon chain that includes the carbon with the oxygen attached. The ending of this compound will have an ane, ene, or ine, and in our case, it will always be ane because we will have only one functional group present. In front of that, we'll place the number of carbons found on the longest continuous carbon chain. Then we're going to treat the oxygen as an attachment, and we'll put in how long the carbon chain is that is attached to the attached oxygen. That will give us prefixes like methoxy, ethoxy, propoxy, butoxy, pentoxy, depending on how long that side chain is. Next, we'll indicate where that oxygen is attached on the main chain. And finally, we'll add in any substituents indicating where they are attached using the numbering direction determined by the oxygen in the previous step. So let's try some. Notice that we do have some common names over here in the parentheses. You will not need to know those at all. So let's start with compound A. Step 1 is to find your functional group. We see our oxygen here. That indicates that there will be oxy in the middle of our name because it's in the middle of this carbon chain. Step 2, find the longest carbon chain. Both sides are one carbon, so it doesn't matter which side you pick. It will be meth. This is methane at the end of its name. In front of that will be our oxy, and in front of that will be meth again because it's one carbon. The next step is to put a number in front of the methoxy group. In this case, that would be number 1 because there's only one carbon. But because there's only one carbon, the answer will not have a 1 in it, since the only possible place to put it was number 1. Now, let's look at compound B. Here we see the oxygen in the middle, so we know there will be oxy in the middle of its name. The ending will be A-N-E because everything is single bonded. We look for the longest hydrocarbon chain. We can see that there is one carbon on the left side and 2 carbons on the right, so we're going to use 2. That means we now have an ethane. We'll put the oxy in front of that, and in front of that we'll put the 1 carbon chain, so it's going to be meth. This becomes methoxy. Sometimes people ask me why it's not methyloxy, and my only answer is that is the way that the IUPAC committee has decided to name it. But it is also useful because it means that the methyl group is not directly attached to the carbon. It's going through an intermediary oxygen. Our next step is to put a number on it. So what number is it on? Coming from the left, counting only the main chain, we see that it is on carbon 1, and coming from the right, it would be on carbon 2. We would put in 1-methoxyethane. In this case, we do not have to put the 1 in because it could only be on carbon 1. If I had drawn it on the other side, you would see that that would still be 1-methoxyethane. Now let's look at compound C. We see there's an oxygen in the middle, telling us that this is an ether, and that oxy will be in the middle of its name. We see 2 carbon chain on each side. Since the 2 sides are the same length, either one can be chosen as your main chain. 2 carbons is eth, so this ending will be ethane. We put oxy in front of that, and in front of that we're going to put another eth for the other 2 carbons. So this is now ethoxyethane. Now we need to number the main chain, and we see that this will be again on carbon number 1. So this would be 1-ethoxyethane, but we will not be using the 1 because it could only be on carbon 1, as we saw in the above example. So the whole name is ethoxyethane. Looking at compound D, we see there's an oxygen in the middle of it, So this is an ether, and telling us that oxy will be in the middle of its name. The ending will be ane because everything is single bonded. Next, we look for the longer hydrocarbon chain, and we see that is on the left-hand side. We see 3 carbons, so this is a type of propane. We put oxy in front of that, so we now have oxypropane, and now we're going to put the 2 carbon chain in front of that, which we put eth for that, and that becomes ethoxypropane. Now we have to put in the numbers. Counting in the forward direction, we see that the oxygen is on carbon number 3. Counting in the reverse direction, we see that it is on number 1. So we will choose the number 1. This is 1-ethoxypropane. Do I need that number 1? We can test if we need the number by putting the ethoxy on a different carbon. As you see here, I put it on the 2nd carbon. This would then be 2-ethoxypropane. And yes, we do need the number. Our original answer is 1-ethoxypropane, and I've drawn in a model of 2-ethoxypropane. And that is our naming of ethers. Now, let's try to draw some. Drawing ethers is fairly easy. Reading the name, we can see that there's an oxygen in the middle of it, so that tells us that it's split in 2. For compound A, we have 3-propoxyhexane. That tells us that the 2 parts are propyl and hexyl. So we got something with a 3-carbon chain and something with a 6-carbon chain. The second name is hex, and that tells us that the longer of the 2 is 6 carbons. We'll start there. Draw your 6-carbon chain. Then on carbon number 3, you're going to attach an oxygen, and to that you will attach 3 carbons. And that is your carbon skeleton. Now we just need to attach the hydrogens. Each carbon needs to have 4 bonds, so each carbon gets enough hydrogens to make up to 4 bonds. Each oxygen gets a total of 2 bonds, and they are already taken. Let's try compound B. We have 4-isopropoxynonane. Because it has an oxy in the middle of its name, it tells us that this is an ether. The fact that it ends with nonane tells us it has 9 carbons in the main chain. Then we can see that there are 3 carbons, because it says prop, 3 carbons coming off of the other side of the oxygen. So let's start with our nonane. We draw our 9 carbons in a straight line. We go to carbon number 4, we put in our oxygen, and on the other side of that we're going to attach a carbon. Now notice that this says isopropoxy, not propoxy. That means I have to put a carbon on either side of that carbon so that we will have an isopropyl group. So we now have our carbon skeleton for 4-isopropoxynonane. Now we just need to add the hydrogens in to make sure that each carbon gets 4 bonds and each oxygen has its 2. And that is 4-isopropoxynonane.